Systematic errors. Experimental science involves the measurement of quantities by measuring instruments. Despite of our best efforts, there are chances that measurement recorded by any instrument contains some uncertainty. This uncertainty is called an error. Measuring instruments measures physical quantities precisely up to certain limits. This limit is known as the least count of the measuring instruments. Can you measure the reading shown by this voltmeter? The smallest division on this voltmeter is 1 volt. The needle of the voltmeter is located just around the 22-volt mark. So, what will be the uncertainty here? According to the rule, half of the smallest division is its uncertain value, which is plus minus 0.5 volt. Therefore, one can report the reading equal to 22.0 plus minus 0.5 volt. Errors in measurement can be broadly classified as systematic errors, random errors. Systematic errors occur to the same extent in each one of a series of measurements. That means it tends to be in one direction, either positive or negative. For example, a thermometer with inadequate calibration may read boiling temperature of water as 103 degrees Celsius instead of 100 degrees Celsius at STP and will give incorrect reading to the same extent consistently while measurement. This means it tends to be in one direction. The main causes of systematic errors are instrumental errors, imperfection in experimental technique or procedure, and personal errors. Instrumental errors. These types of errors arise due to imperfection in design or calibration of measuring instruments like thermometer, voltmeter, ammeter, meter scale, and screw gauge, etc. Instrumental errors in vernier caliper and screw gauge arise when zero mark of the vernier scale and screw gauge may not coincide with the zero mark of the main scale. This is known as the zero error of the instrument. Another cause of systematic errors is imperfection procedure and experimental techniques. For example, if a thermometer is placed under the armpit, it will show a lower temperature as compared to the actual body temperature. Personal errors. Personal errors arise mainly due to the lack of proper setting or positioning of measuring instruments. A simple example of personal or human error is parallax error, where one observes the scale of a measuring instrument at an angle, rather than from directly in front of it, that is, perpendicular to it. If this is done consistently, it introduces a systematic error into the results. Here, the observation recorded by student B is correct. Rest of the students observed the scale incorrectly due to parallax error. Systematic errors can be minimized by using better instruments, improving experimental techniques, and removing personal errors as far as possible.